we look at the rational function y equals x plus 7 quantity squared over x plus 5. This is just the reciprocal of the function we did in the preceding, but we're not going to analyze it in that manner. We could analyze it based on the preceding graph, but we're not going to do that in this course. Okay. Numerator has degree 2. It's a polynomial of degree 2. Denominator is a polynomial of degree 1, so it is a rational function. And it has oblique asymptotes since the degree of the numerator is 1 more than the degree of the denominator. Okay? Numerator is 0 if x equals negative 7. Denominator is 0 if x equals negative 5. Very clear. So the 0 of the function is at the point negative 7, 0. Well, that's going to be a point on the graph. We have vertical asymptote at x equals negative 5 because at x equals, as we approach x equals negative 5, the denominator approaches 0. The numerator stays close to 4 because if x is negative 5, you get negative 5 plus 7 is 2. Square that, you get 4. So you're dividing a number near 4 by a number that approaches 0. The y-intercept is at 49.5, and actually if we want to label that as a point, we could say it's, now there isn't room to do that. So we'll just write that as 0.49. That's about 0.10. So we already have a lot of information. We have a 0, we have a y-intercept, that's 2 points, and we have a vertical asymptote. And we'll analyze that a little further in a minute. Okay, we have an oblique asymptote. Because the degree of the numerator is 2, the degree of the denominator is 1. Now, the numerator is x plus 7. We square that, and that's very easy to square. We get x squared plus 14x plus 49. And we're going to divide that by the denominator. We're going to do a long division. Long division in this case is fairly simple. X goes into x squared, x times. X times x plus 5 is x squared plus 5x. We subtract that from the x squared plus 14x we have here. We get 9x plus 49. X goes into 9x 9 times. 9 times x plus 5 is 9x plus 45, giving us a remainder when we subtract here of 4. Now that means remainder is 4. We put the 4 over the x plus 5. So now we see that y equals x plus 7 squared over x plus 5. And in this form we were able to get all this information. But that also equals this. It's x plus 9 plus 4 over x plus 5. Now the convenient thing about this is when we do our end behavior, when x gets really large, 4 over x plus 5 is going to approach 0, which means that our function is essentially just going to be x plus 9. X plus 9 plus something that becomes increasingly insignificant as x gets large. So that the oblique asymptote is y equals x plus 9. That's a line with y-intercept 9, slope 1. Okay, so now how do we put all this together? Well, I'm gonna pause for a second and write some things on the board so you don't have to watch me do that. And in the meantime, and of course it's going to be a very short time from your perspective, I want you to put this information together on a graph as best you can. Okay, putting that information together. First of all, we know that we have a 0. That's at the point negative 7, 0, so we sketch the point negative 7, 0. We know we have a vertical asymptote at x equals negative 5, so we sketch a dotted line at x equals negative 5. And we know we have an oblique asymptote that's going to take care of our large x behavior, our end behavior, and that's going to be y equals x plus 9, obtained by this long division that changes the form of the function from this to this. So we draw that line, y equals x plus 9. Now I used an exaggerated scale in the x direction a smaller scale in the y direction, so that doesn't look like a slope of 1, but that's just because of the scale. 49/5 is close to 10. This is -7. The 7 here is bigger than the 10 here, so the line doesn't look quite right. But it will intercept. The line y equals x plus 9 will intercept the y-axis at 0, 9, and the x-axis at -9, 0, somewhat to the left of -7, 0. Now, one thing we can notice is that there are no zeros. To the right of x equals -5. So from here on, there are no zeros. Now the graph is positive here, and it can't be negative any place on this side of the x equals -5 line because there are no zeros. You'd have to have a zero in order to pass through the x-axis. So if the graph was to pass through the x-axis, well, it just can't because there are no zeros. Okay, now to the right of x equals -5, x plus 5 is positive. X plus 7 squared is positive. So everywhere to the right this is positive, and this asymptote we have at x equals -5 is going to come down from here, like so. Might go through this line x equals y equals x plus 9. It might not. It might just come down through here and just kind of slump into this asymptote at y equals x plus 9. There's a way to determine that, but we're not going to make that distinction. So you could draw it like this, although if you drew it like this, that would be perfectly acceptable. It could be either of those, and for reasons that we're not going to worry about at the level of this course at this point. Okay? On the other side of x equals -5, x plus 5 is negative, x plus 7 squared is positive, so that the graph has to stay, it can't go above the x-axis. Now, we have this 0 at -7. The graph is going to have to come up from an asymptote, a negative asymptote. It's going to approach the line x equals -5 through negative values. Now that would seem that as you come up here and go through this point, which would take it into positive values. It can't do that because, again, x plus 5 is going to be negative everywhere from here over. X plus 7 squared can't be negative. So what are we going to do about that? Well, you might want to think about that for a minute. I'm going to draw a slightly more compact graph, and we're going to look at what happens on this side of x equals -5. We do know it's approaching a negative, the asymptote with x equals -5 through negative values, so it's approaching negative infinity here. Okay, this graph is more to an equal scale. 9 units here, 9 units here look about the same. Graph looks like it has about a 45-degree slope. Looking at the behavior to the left of x equals -5, as we know, we come up through here, and we've got to come up and go through this point. Okay, how are we going to do that without crossing over the x-axis, which we cannot do because we know that on this side the numerator is positive and the denominator is negative. On this side of the line, x equals -5. Positive numerator, negative denominator means that everything has to be negative. The value of the function has to be negative, except at this point. Well, as you should have picked up, hopefully, at least I would hope you'd picked it up, although not everybody will. This x plus 7 is squared, which means that the function is going to approach this -7, 0 sort of as a parabola with a vertex here. Now, I'm not going to go into deep explanation of that. That's just what happens. But we did have an explanation of that previously in the course. So we're going to do something like this. We're going to hit this point and turn around. Just kiss the axis at this point and then turn around. I turned too much. I got carried away with the parabola idea. And then we're going to approach this asymptote y equals x plus 9 in the negative direction. Okay, well, as you can see from this example in the preceding, there's a lot that goes into graphing a rational function. It's probably one of the more challenging things we ask you to do in this course. For the test, I'll say that the degree of the numerator won't be greater than 2, the degree of the denominator won't be greater than 2. And this means that you're going to be able to find the zeros of the numerator and the zeros of the denominator, even if I write this out in expanded form, and even if it was x plus 7 times x plus 3, you would still be able to find the zeros. We'll do an example of that next.